Gold. The very word evokes images of grandeur, opulence, and perhaps a touch of bling. But what happens when we shrink this precious metal down to the nanoscale, a realm so small it's practically invisible to the naked eye? We enter the fascinating world of gold nanoparticles. These tiny particles measuring billionths of a meter possess unique properties that have captivated scientists and engineers alike. Their small size and large surface area make them incredibly reactive, opening up a world of possibilities in fields like medicine, electronics, and environmental science. Imagine for a moment a future where targeted drug delivery systems attack cancerous cells with laser-like precision, or where pollutants vanish from our waterways thanks to the magic of nanotechnology. That's the exciting potential that gold nanoparticles hold. But there's a catch. Traditional methods for synthesizing these nanoparticles often involve harsh chemicals and leave behind toxic residues, casting a shadow over their otherwise brilliant applications. Fear not, for science has a knack for turning challenges into opportunities. Enter the era of biodegradable gold nanoparticles, a game-changer in the field of nanotechnology. These eco-friendly nanoparticles are synthesized using sustainable materials and methods, ensuring that their brilliance doesn't come at the cost of our planet's health. Traditional methods of creating gold nanoparticles often resemble a heavy metal concert, loud, messy, and potentially hazardous. Harsh chemicals are the headbangers of this process, often leaving behind toxic byproducts that linger long after the music stops. These chemical residues can pose significant risks to human health and the environment. Imagine these toxic remnants infiltrating our water sources, or accumulating in the food chain. Not exactly the glamorous image we associate with gold, is it? The very properties that make nanoparticles so promising, their tiny size and reactivity, also make them challenging to manage. They can easily slip through filtration systems and persist in the environment, potentially wreaking havoc on ecosystems. Clearly, the traditional approach to nanoparticle synthesis was like trying to extinguish a fire with gasoline, not the most sustainable solution. The need for a greener, more eco-friendly approach became glaringly apparent. Science, never one to shy away from a challenge, answered the call with the development of biodegradable gold nanoparticles. Imagine a world where the creation of gold nanoparticles is as gentle as a spring rain, leaving behind no harmful residues. This is the promise of biodegradable nanoparticles. These tiny wonders are engineered to break down naturally over time, leaving behind no toxic trace. Think of them as the disappearing ink of the nanoworld. But how does one convince gold, a metal known for its permanence, to simply fade away? The secret lies in the clever use of biodegradable materials in the synthesis process. Instead of relying on harsh chemicals, scientists have turned to nature's toolbox, borrowing ingredients from the plant kingdom and the world of biopolymers. These natural components act as scaffolding during the nanoparticle formation, guiding the gold atoms into their desired structures. Once their job is done, these biodegradable materials gracefully bow out, breaking down into harmless byproducts that nature can easily handle. This shift towards biodegradable nanoparticles is more than just a trend. It's a fundamental change in how we approach nanotechnology. It's about recognizing the interconnectedness of our technological advancements with the health of our planet. It's about ensuring that the brilliant solutions we develop today don't come back to bite us tomorrow. Let's meet the eco-warriors of the nano-world: biodegradable polymers and plant extracts. These natural heroes create gold nanoparticles that are effective and eco-friendly. Biodegradable polymers break down naturally, guiding nanoparticle formation. Plant extracts add antioxidants, aiding synthesis and adding properties. Imagine gold nanoparticles with the healing properties of plants. Sustainable synthesis unlocking new possibilities. Section 5. Green Solutions for a Golden Age: Applications in Medicine. Biodegradable gold nanoparticles are revolutionizing medicine. They offer precise cancer treatment, minimizing side effects. These nanoparticles can also be used in photothermal therapy. Beyond cancer, they promise advancements in biosensing and wound healing. Section 6. Environmental remediation, cleaning up with gold. Pollution, the unwelcome guest that overstays its welcome, is a global challenge demanding innovative solutions. Biodegradable gold nanoparticles, with their eco-friendly nature and unique catalytic properties, are emerging as powerful allies in the fight for a cleaner, healthier planet. These nanoparticles can act as tiny sponges, absorbing pollutants like heavy metals and pesticides from contaminated water sources. Imagine deploying swarms of these nanoscopic cleaning crews to purify our rivers and lakes, restoring them to their pristine glory. But their talents don't stop there. Biodegradable gold nanoparticles can also be used to degrade harmful organic pollutants, breaking them down into less harmful substances. Their catalytic abilities, enhanced by their small size and large surface area, make them incredibly efficient at accelerating these degradation reactions. It's like having an army of microscopic Pac-Men chomping their way through pollution. Furthermore, these nanoparticles can be integrated into sensors to monitor environmental pollutants in real time. Imagine a network of these nanosensors deployed across a city, providing up-to-the-minute data on air and water quality. This information would enable us to take timely action and prevent environmental disasters before they occur. Section 7. Proof in the Petri dish, efficacy of biodegradable gold nanoparticles. While the potential of biodegradable gold nanoparticles is undeniably exciting, it's essential to back up the hype with cold, hard data. Fortunately, these nanoparticles have proven their mettle in laboratory settings, demonstrating remarkable efficacy in a range of applications. Studies have shown that biodegradable gold nanoparticles can effectively deliver drugs to cancer cells, significantly inhibiting tumor growth in vitro. Imagine petri dishes filled with cancer cells retreating in the face of these golden warriors, their growth stunted, their reign of terror coming to an end. In the realm of environmental remediation, these nanoparticles have demonstrated their ability to remove heavy metals like mercury and lead from contaminated water samples with impressive efficiency. Imagine watching as polluted water, once murky and lifeless, becomes clear and vibrant again, all thanks to the cleansing power of these nanoparticles. Furthermore, biodegradable gold nanoparticles have shown promise in degrading organic pollutants, breaking them down into less harmful substances. Imagine a future where the toxic legacy of industrial waste is erased, replaced by clean water and healthy ecosystems. These laboratory studies, while just the first step in a long journey, provide compelling evidence of the potential of biodegradable gold nanoparticles to revolutionize both medicine and environmental science. Section 8. The future is golden potential innovations. The journey of biodegradable gold nanoparticles has just begun, and the road ahead is paved with exciting possibilities. Imagine a future where these nanoparticles become an integral part of our lives, seamlessly integrated into our healthcare systems and environmental protection strategies. One promising avenue of research is the development of smart nanoparticles that respond to specific stimuli in the body, such as changes in pH or temperature. Imagine nanoparticles that release drugs only upon reaching their intended target, minimizing side effects and maximizing therapeutic impact. Another exciting frontier is the use of biodegradable gold nanoparticles in regenerative medicine. Imagine using these nanoparticles to stimulate tissue regeneration, repairing damaged organs, and even reversing the effects of aging. In the realm of environmental science, the potential applications are equally vast. Imagine using biodegradable gold nanoparticles to develop self-cleaning surfaces for buildings and vehicles, reducing our reliance on harsh cleaning agents. Imagine deploying these nanoparticles to clean up oil spills and other environmental disasters, restoring balance to our planet. The possibilities are as limitless as the human imagination itself. As we continue to explore the unique properties and applications of biodegradable gold nanoparticles, we are unlocking a future where innovation and sustainability go hand in hand. Section 9. Conclusion. A shining beacon of hope. In a world grappling with complex challenges, biodegradable gold nanoparticles stand as a shining beacon of hope. They represent a paradigm shift in nanotechnology, one where innovation is no longer synonymous with environmental degradation. These tiny particles, engineered with precision and care, have the potential to revolutionize medicine, clean up our planet, and usher in a new era of sustainable technologies. As we venture further into the nano world, let us remember that the true measure of progress lies not only in the brilliance of our inventions, but also in our commitment to safeguarding the health of our planet and future generations. Biodegradable gold nanoparticles are a testament to the power of human ingenuity when guided by a deep respect for nature. They are a reminder that the most sustainable solutions are often found by looking to the natural world for inspiration. And as we continue to unlock the secrets of these tiny golden wonders, one thing is certain: the future is bright, and it's undeniably golden.